So we're moving on to 8.2, and we're talking about the areas in the plane. So we had a problem that actually fits into this section that was in the workbook. That was where we did the two areas and we subtracted them. That's what we're doing today. So the whole idea is if it's not just an area above the x-axis, it's actually an area that's segregated from the x-axis. So what we're going to do is the area equals from A to B of f of x minus g of x dx. We're subtracting the two different graphs. But here's the fun part. If it's with respect to x. So that's usually what we have is if everything is above the x-axis and we're looking at it that way. So I'm going to write x-axis here when I say that. And that means we're going to take the top function and subtract the bottom function. If, this is our fun one, if it's with respect to y. Which means if you look at it, you can go from one side to the other to the y-axis. Kind of do it sideways. We're going to take the right and subtract the left. Okay? All right. So here's the deal. I'm going to give you some steps that I think it's easiest to follow. So step one, what you want to do is find the intersection point. All right, and you can do that either with the calculator or we can do it algebraically. So today, I think problems 1 through 5, they actually give you the bounds. All right, so that's going to be already done for you for the first 5. If we're doing it algebraically, what we're doing is we're setting equal to each other and solving. All right, so step 2, once we find what those bounds are, we're going to set up our area integral. Step 3, we're going to find the antiderivative. And then, of course, 4, we're going to evaluate with the bounds from the intersection. All right. Let's do example number 1 so you guys can get a better picture of what's going on, okay? So here's example number 1. Let's say I want you to find the area enclosed by y equals 2 minus x squared and y equals negative x. All right, so let me kind of draw you a picture of what that looks like. So first of all, y equals 2 minus x squared is an upside down parabola that's moved up 2, right, opens down. So here's this parabola. And then this line right here is just this diagonal line that goes through the origin. So what we're looking for is this shaded region right here. And since we're going from the top to the bottom, this is with respect to x. It's always y equals. So this is going to be normal. All right, so first we have to find out where these 2 points are. We need these, right? To do that, we're going to set these equal to each other. So I have negative x equals 2 minus x squared. I'm going to add or move everything over to the left. So I get positive x squared minus x minus 2 equals 0. Then I get to factor, right? Negative 2 on top, negative 1 on the bottom is going to be negative 2 and 1. So I have x minus 2 and x plus 1. So my two bounds are going to be where x equals positive 2 and where x equals negative 1, which makes sense. This looks like this is about positive 2 and that's about negative 1. So those are my bounds. All right, so then step 2, we're going to write our area integral. We have a equals the integral from negative 1 to 2. Make sure you write them in the right order. And then I think you guys would rather put them together all in one integral. So that's how I'm going to write it. First one we have is the top one, which is the parabola. So top minus the bottom. And then I'm going to put the brackets in right now, but they're going to end up going away, just so you see that's how it's set up. So I think the easiest thing for us to do before we find our antiderivative is let's simplify that up a little bit, right? I mean, we can distribute our negatives, collect like terms, okay? So I'm actually going to have the integral from negative 1 to 2 of 2 minus x squared plus x. And then technically it's dx. All right, so let's find our area. So antiderivative of 2 is 2x. Antiderivative of negative x squared is negative x to the third over 3. And then antiderivative of x is x squared over 2. We're going from negative 1 to 2. All right, plugging in 2 first, I get 4 minus 8/3 plus 4 over 2, which is 2, minus, plugging in negative 1, negative 2, I mean negative 1/3, but the negative makes it plus 1/3 right here. And then negative 1 squared is a positive 1, so plus 1/2. Let's see, that's 6 minus 8/3. 18/3 minus 8/3 is 10/3. Minus, in this one, this would be a, let's see, negative 7 over 6. So 10/3 plus 7 over 6, that's 20 over 6, so 27 over 6, which reduces to 9 over 2, or we can say 4.5. So honestly, the hardest part of today is actually setting up what minus what, because a lot of the integration is going to be pretty straightforward. There's no u substitution, there's no by parts, there's none of that, okay? It's straight integration for all of them. All right, so questions before I go to the next example. Okay, all right. Let's do another one then. Example number 2. All right, find the area between y equals x squared minus 1 and y equals negative x plus 1. So again, for me, the easiest thing to do is to sketch the graph so I can see what it looks like. So if I sketch this graph, this is a parabola that's moved down 1. So here's my parabola that's moved down 1. And then this is a line that's gone up 1 and has a slope of down 1 and over 1. So my line would be like this. And so this time I'm looking for this area in here. All right, so again, the first thing I have to do is figure out what this point and this point is. I'm going to set them equal to each other. So x squared minus 1 equals negative x plus 1. move everything over. So I get x squared plus x. Let's see, subtracting 1 over -2 equals 0. -2 on top. This time I have a positive 1 on the bottom, so I get 2 and a -1. So we have x plus 2 times x minus 1. So this time my x values are -2 and +1. All right, so let's set up our area integral. That goes from -2 to 1. Gotta make sure we put it in the right order, of course. The top one this time is our line. So we're going to take -x plus 1 and subtract the parabola, which is underneath, the x squared minus 1. And of course, dx at the end, blah, blah, blah. All right, so let's simplify this up just a little bit. A equals the integral from -2 to 1. I have -x plus 1 distributing -x squared plus 1. So I have in my integral -x squared minus x plus 2. All right, so let's do our antiderivative. Antiderivative of -x squared over, or -x squared is -x to the third over 3. -x is -x squared over 2 plus 2x. And we're going from -2 to 1. So if I plug in 1, I get -1/3 minus 1/2 plus 2. And then minus, I'm going to plug in my -2. I'd be -8 with a negative makes a +8/3. -2 squared is 4 with a negative in front, divided by 2 is -2. And then minus 4. All right, simplifying this one up, I get 7/6 minus, and in this one I get -6 8/3, so -10/3. Add the two together, and again, you can leave it as, you can do it as a decimal, you can do it as fraction, it's up to you. This again is 4.5. So two major new things are finding the bounds and, of course, setting up the integral. So now, I said at the beginning that it can go from either respect to x, which we've been doing, that's normal for us, but there's also with respect to y. So I want to do an example like that, okay? So here's example number 3. And it could happen 2 different ways. Sometimes they give it to you already as x equals, and sometimes they give it to you as y equals, and then you have to move it over. So we're going to do this one with the area with respect to y. All right, and I'm going to put them as x equals because I think that'll be easier. So we have x equals y squared is the first one. And our second one is x equals y plus 2. All right, so let's graph these so we have an idea what's going on. So to graph them, though, it's easier if I graph it with y equals, right? So graphing this one, for example, let me put this in a different color. To get y by itself, I would square root of both sides. So really, I'm graphing y equals the square root of x. And this one, to get y by itself, I'm graphing y equals x minus 2. So graphing this one, that's just the square root, starts at 0 and does this. And then the other one is a line that technically would come down by 2 and would go up and over 1. So something along this line. Okay, so now you'll notice that here we have this area underneath, so to speak, that makes it a little bit harder to work with. We can actually do our graph going this direction because we want to find this area right here. Stay in the area. Nobody said I could color very well. All right, so this one with respect to y means that first we have to find what the y value is here and the y value is here. Okay, so obviously the y value here is -2, right? We need to know what this y value is where the intersection is. So we're going to take our two equations, set them equal to each other. So I have y squared equals y plus 2. Moving it over. Y squared minus y minus 2 equals 0. -2 on top, -1 on the bottom. I think we've done this one a couple times. We have y. Oh, Trevor's here. All right, we have y. -2 times y plus 1. Right, and so actually we can say that our y equals +2. And this says that they intersect at -1. Oops. Now, technically it doesn't intersect because it's right on the y-axis, right? So really my y value here at this point, if I'm looking at it from this way, it would be +2. Or sorry, -2, sorry, -2. So we want the area from here to here. Because this graph doesn't keep going, right? If it did, that would give us this -1 that we got when we got it algebraically. Does everybody understand that? Okay, but this doesn't keep going. It stops. Okay, good deal. All right, so why don't we on this one, let's just do the area. Instead of doing the area from here to here, why don't we just do this area? Okay, so it's blocked by the x-axis. And so it's just this little piece right here. So we're going to go from where y equals 0 to where y equals 2. All right? So let's set that area up, find that piece. So we're going to do the area equals the integral from 0 to 2. And then remember when we're doing it with respect to y, we do the right side first, which is the line, right? So that's y plus 2. And we subtract the other one, which was the curve, which was y squared. So this is the integral from 0 to 2. Distributing my negative, I get y plus 2 minus y squared. Does it matter what order I have my terms in? It doesn't, right? Because now we're going to do the antiderivative of that. So in this case, y becomes y squared over 2. 2 becomes 2y. And -y to the second becomes -y to the third over 3. We're going from 0 to 2. So plugging in 2. Excuse me. I have 2 squared, which is 4, divided by 2 is 2. Plus, if I go from 2 times 2, this is 4. And then plugging that in, that's -8/3. My first one, minus. Now, if I plug in 0, I just get 0, because they all have y's in them. All right, so simplifying this is 6 minus 8/3, or 18 over 3 minus 8 over 3, so this is 10/3. Is that what everybody else got too? Okay. All right, so there's only one more thing having to do with these that I want to talk about, which actually will impact you in a couple of the problems when you do 1 through 10 today. So last example, I'm going to take questions, and then I'm going to have you get started. Just example number 4. Now, 1 through 6, they've drawn out for you already, and they've given you the set bounds. So I want to do something similar to that so you have an idea. There's one thing I want to show you. So let's say we have y equals x squared plus 1, and we have y equals negative x squared minus 1, but they want you to find the area from negative 1 to 1. So they have actually drawn you a picture. Right, I have one parabola that opens up, which is right here. This one is a parabola that opens down. Okay, and then you're only doing the area from negative 1 to positive 1. Okay, so we're doing this beautiful little area right in here. Okay, so again, they've already given you your bounds, so you don't need to find those. When we do our integral, we're going from negative 1 to 1 of the top curve, which is the one that opens up. That's the x squared plus 1 minus the bottom curve, which is the negative x squared minus 1. We can simplify that up and say we have the integral from negative 1 to 1 of 2x squared, right, if I distribute my negative, plus 2. All right, so let's go ahead and integrate this. So 2x squared becomes 2x to the third over 3 plus 2 becomes 2x from negative 1 to 1. Move that up a little bit. If I plug 1 in, I get 2/3 plus 2 minus, if I plug in negative 1, I get negative 2/3 minus 2. Let's see, this is 8/3 minus a negative 8/3, which gives us 16/3. Okay, now here's what I want to show. You'll notice that the first half had an area of 8/3 and the second half had an area of negative 8/3, right? Because it was subtracting. So if you look at our picture, you actually can see that this is symmetrical, like they're two like equal halves. So another way to do this is you could have done, and you may want to do this, it's up to you, the area of the integral and only do half of it from 0 to 1, and then times it all by 2 when you're done, because you have 2 equal pieces. And so by doing it that way, let me get this here, when you do your antiderivative, which was the 2x to the third over 3 plus 2x, and I plug in my 1, I'm going to get my 8/3. Move it up a little. But then when I plug in 0, everything disappears, right? So I really don't have to do the work of doing my 0, 1. And then I'm going to times this by 2, and look at that, we get 16/3. So if it's symmetrical, or the two sides are equal, you can just do half and times it by 2. Okay, I want you guys to realize that that's a possibility. And that's actually numbers 2, 5, and 6. All are symmetrical. You can do half of it if you want to. You don't have to. Right? But it is another way for some people. If you happen to look somewhere else or refer to another site or anything, they're probably going to do it this way. So I want you to understand what you're seeing. Okay? All right, you guys, give me questions over this section. What do you think? Okay. All right. Okay. So yeah, we have, we'll probably do 8-2 when we get back from break, and then 8-3, and you guys are done. 8-3 just takes these different shapes and spins them around the x or the y axis and makes like volume, makes a shape. And so you're finding volume instead of just the area, which is kind of cool. So this is all that's due for tomorrow. If you don't have any questions over it, you don't have to meet tomorrow. I will be on at 11 in case you have questions. Other than that, we are done until after break, okay? Awesome, right? So. All right, you guys. If I don't see you tomorrow, have a great vacation. I hope I get to see you on the 5th face-to-face. I'm really crossing my fingers. You guys take care of yourselves, and if I see you tomorrow, awesome. I'll tell you the same thing tomorrow, okay? Let me know if you need anything, all right? Bye, guys.